Okay, pre-cal 10. Here we go, video number 10. We just finished video 9 talking about the three different forms of linear equations. So in this video, we're going to look at a few special cases and then how we can work with those three equations to determine particular sets of information. So here we go. We'll start with something we've seen before, a y equals line. So what does it mean to be the line y equals 3? That's all the information you get, and it doesn't seem like enough. But there is somewhere where y equals 3, right? Where does y equal 3? Right here, my y-intercept. But where else does y equal 3? Here, 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 everywhere. Everywhere, doesn't matter what x is, anywhere along this horizontal line, y equals 3. So when we get a y equals line that is given a number, y equals 1, y equals -2, right? Those are just horizontal lines at that point. So just think the y is telling you the y-intercept, and then it's just a line that cuts through there. And that is a y equals line. And then obviously a little bit counterintuitively, the x-axis is a y equals line, and it's y equals 0. So every horizontal line is a y equals line. So next we have an x equals line. Well, what does that look like? Well, let's just say we have x equals 3. Well, where does that occur? That occurs at my x-intercept, here. Where else? Here, 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 here. Anywhere along the vertical line that cuts through the x-axis at 3. So vertical lines are x equals lines. So x equals -4 would be the vertical line through -4. And then again, now this time we have the y-axis, which is a vertical line at x equals 0. You're going to see vertical and horizontal lines more and more often when you get into nonlinear equations and things called asymptotes. We looked at them briefly, but you will see them, so try to get as comfortable as you can with them. So let's look now at what do we do if we're given 2 points and we need to find the equation of a line. Well, we know we have a few equations we could try to use. We have slope-intercept form, and we have point-slope form. Remember that slope-intercept was y equals mx plus b, and point-slope was y minus y1 equals m times x minus x1. And the thing is, for both of these right now, we do not have slope, right? We don't have m for either of them. But given 2 points, we can find m. Because remember, our slope is equal to y2 minus y1 over x2 minus x1. And I'm going to call this point 2, and I'm going to call this point 1. So let's find our slope. -4 minus 2 over 1 minus 5 gives us -6 over -4, which gives us positive 3 over 2. So now we have a slope, and I'll show you it doesn't matter which point you use, and it doesn't matter which equation you use. So for slope-intercept, I will use 5, 2, and for point-slope, I'll use the other one. I'll use 1, -4. And you'll see that no matter what, we'll get the same equation. So for slope-intercept form, we have the y, and we have the x, and we have the m. We just don't have the b, so let's plug in and find it. So 2 equals 3 over 2 times x, which is 5, and then plus b. So now we're going to do a bit of algebra, a bit of arithmetic. 2 equals 15 over 2 plus b. We're going to subtract 15 over 2 from both sides. We get 2 minus 15 over 2 equals b. And then I need a common denominator for this 2. So 2 is equal to 4 over 2. So we will just go 4 over 2 minus 15 over 2 equals b. So b equals -11 over 2. So with that information, we can then just write the equation y equals 3 over 2x minus 11 over 2. So that is the equation of the line that passes through the 2 given points. Well, what if we were to use point-slope form? Well, okay, we'll use the other point in this case. Y minus -4 equals 3 over 2 times x minus 1. which is y plus 4 equals, multiply that in, 3 over 2x minus 3 over 2. And we'll put it into slope-intercept form as well, just to show you that the equation is the same. So minus 4 from both sides. We now get y equals 3 over 2x minus 3 over 2 minus 4. But look at the top right here. What is 4? 4 is equal to 8 over 2, because we need a common denominator. So we'll come back to our equation. We'll change the 4 to 8 over 2. And that gives us y equals 3 over 2x minus 11 over 2. So we get the same equation. We would expect the same equation, but it just shows you that you can use either form and you can use either point. And if you do all your algebra and arithmetic properly, you won't make any errors. So what about parallel lines? Well, parallel lines, very important distinction, have the same slope, which means if we were to draw a line here with a slope of 1, 1 over 1, 1 over 1, 1 over 1, we could draw a parallel line here, 1 over 1, 1 over 1, 1 over 1, same slopes. Those two lines are never going to cross. They're parallel. They have the same slope, so they're never going to cross. And it's a very important distinction here is that they have different y-intercepts. Why does that matter? Well, because if they had the same y-intercept and the same slope, then they would just be the same line. It would just be one line lying on top of the other. So they have different y-intercepts and they have same slope. If you get that scenario, you have parallel lines. So if you're given a couple equations and it's asking, are they parallel? Well, we need to check their slopes. So we're going to need to use some algebra to get into y-intercept form, or slope-intercept form. So now if you look here, I have my y by itself. There's no coefficient. I just need y to be positive. So rather than moving the x around like we normally would, let's just add y to both sides. Because now I get the equation 3x equals 5 plus y. It's almost the same, but now I got to subtract 5 from both sides, and you get 3x minus 5 equals y. Now I hope that you can understand that that is exactly the same as that. It's just rearranged and looked at in a different perspective. So there we go. The first one has a slope of 3. Okay, so what about this one? Well, let's add 6x to both sides. And we get 2y equals 6x plus 12. And then we have to divide everything by 2. And we get y equals 3x plus 6. So you can see we have different y-intercepts, which is good. And we have the same slope, which means that yes, these are in fact parallel lines. So we need to find the slopes to make that determination. Okay, so what about perpendicular lines? Okay, so perpendicular lines are lines that cross one another. An important distinction, when they cross, they create a 90-degree angle. That makes two lines perpendicular. And the special thing about their slopes is that their slopes are what we call negative reciprocals. So remember that a reciprocal, 2 over 3, has a reciprocal of 3 over 2. We use this sometimes to help as a little memory game. Refliprical. So if you flip a fraction, you get its reciprocal. And in this case, we need a negative reciprocal, which means if we have positive 2 over 3, it would be negative 3 over 2. If we had negative 3 over 2, it would be positive, or 2 over 3 would be positive 3 over 2. So let's just look at these two lines. Let's look at the blue line first. Okay, we count down 1, 2, 3, 4, 5. So negative 5 and over 2. So the blue line has a slope of negative 5 over 2. The red line, it has a slope of 1, 2, 3, 4, 5, 1, 2. So 2 and 5. So you can see those two slopes are negative reciprocals of one another, which means that these two lines are in fact perpendicular. So what if you don't have a graph? What if you just have equations? Well, again, we're just looking at comparing the slopes, so it's going to be algebra. So get into slope-intercept form. Subtract x from both sides. 2y equals negative x plus 6. and then divide everything by 2, and we get y equals negative 1/2 x plus 3. The second one, we're going to add 2x to both sides, and we get y equals 2x plus 3. So here, slope of 2, and here, slope of negative 1/2. 2 over 1 has a reciprocal 1/2, and in this case we have a negative, so we're good. So they are perpendicular. So the last question is, well, given two equations, are they perpendicular, are they parallel, or are they neither? Basically, it means they have the same slope, they have the negative reciprocals, or they just have different slopes that don't match those two things, and it means they're not perpendicular or parallel. So again, let's algebra this thing to find the slope. Minus 4x minus 4x, 3y equals negative 4x plus 7. Divide by 3, divide by 3, divide by 3. Y equals negative 4 over 3x plus 7 over 3. So we get our first slope at negative 4 over 3, which means we're looking for that, or we're looking for that. Okay, if we get this, we have a parallel line. If we get this, we have a perpendicular line. So let's now look at this one. We're going to subtract 2x, negative 4y equals negative 2x plus 4, and then divide by negative 4, divide by negative 4, divide by negative 4, and we're going to get y equals 1/2 x minus 1. So we have a slope of a half. Now those two slopes are definitely not negative reciprocals, and they are absolutely not the same. So in this case, we just say these lines are neither. They're just two lines. Okay, so this connects to section 3.2 and supplements the notes. So the notes still contain a lot more additional information, but use both to further your progress as best you can. Great work, and I'll see you next time.